This video should help to get you set up to use ImageJ software to take measurements on your specimens. Okay, so you'll have your specimen and then a set of others to take measurements from. I think that you'll take a total of measurements on a total of 10 specimens, and then we're going to combine those together. So first thing you want to do is to, of course, open up the software. It's called ImageJ software. It'll pull up as Fiji. Fiji is just like the graphical user interface. Looks like this. Here's your software. Okay. To get pictures in there, so these are pictures that I've taken of Mill Museum in the past here. Some the other of your classmates have taken, but we're just going to work with these. It'll be the same, right? So you'll open up your folder, and this is why you need to have the magnification on here. So we want to only work with pictures all taken at the same magnification. So I'm just going to throw a few specimens in here. The habitus picture at 200x. You just take your picture, drag it into this little part of the software, right? And we'll open it up. Drag the same for 54-6. These are from the Flint farm. I'm going to get the 200x habitus. This is one from up on top of Pine Log Mountain. We'll go with a couple more. 200x habitus. Looks a little bit better. Throw it in there. Okay. We'll do one more. Yeah, 200x habitus. Now, so you'll get all of your tardigrade specimens. And then there's one other thing you need, and it will be in this folder. It's the ocular micrometer. So what this is it's a slide. It goes on to the microscope, and it has small gradations on it. Right? So this is what it looks like if I take a picture at 40x with low magnification. You see the whole scale bar on here. This is the cover slip. Right? And obviously then if I zoom in a little bit more, I see a little bit less of it. 200x. Alright, we're going closer, and then at 400x you just see relatively few of the gradations. So a note here is that each of these small subdivisions on here equals 0.01 millimeters. So from here to here is 0.01 millimeters. We want to do everything in micrometers. So basically that tells me it's 10 micrometers from here to here. Okay. Or, of course, from here to here is going to be 100 micrometers since there are 10 micrometer subdivisions. Okay. So we were pulling 200x specimen pictures. We're going to drop the 200x micrometer photo in there. Okay, because what we need to do, we see on here that this is measured in pixels. So if I want to do a measurement and I want to say from this distance to this distance, which I told you is 10 micrometers, if I draw a line, so I just click on the line tool and I draw a line from here to here, and then you could do Control M, and it will give you the measurement. Right? Ooh, 666. Very interesting. That tells me that this line from here to there is 666 pixels, which is not very useful. Okay, because we don't want measurements in pixels. We want measurements in micrometers. So what we need to do is basically tell the computer how many pixels equals how many micrometers. Okay, so to get started to do that, it's going to be here in the set scale. Right? So, but we need to know this many pixels is equal to this many micrometers. Okay, so we'll come back to this, but right now we need to have a known distance and the equivalency in pixels here. So what I would do is go back here. Okay, I'm gonna clear these out. I'm not gonna save them. I'm gonna do 10 micrometers. Right, so I'm gonna measure from the left side of this line. So if you watch the little cross here, as I move onto that black line, you see the white. So right there, I've hit the edge. Right there, I've hit the edge of the black line on the micrometer. Right. So I'm going to start at the left edge here, and I'm going to go over 10, and I'm going to go just the same right to the edge of that one. Right. I'm going to hit Control M. That tells me that 648 pixels is equivalent to 10 micrometers. But I want to do this a number of times. We want to get an average. So we're going to have some, each time you do it, there's a little bit of error. I'm going to do 10 from here to here, Control M. I'm going to do 10 from here to here. Control M, measurement. I'm going to do, say you do it 6, 7, 10, whatever you have forgot to do. 10 from here to here. Control M. It's good practice. If you're good at this, you should have relatively consistent numbers over there. Right. Here to here. Control M. From here to here. Control M. Alright, so we're getting a few, and we'll see some consistency. Ranges minimum 648, maximum 666. So what we can do is go to results, summarize, and it will give you an average. We go over here, we get to 656. 656. Alright, so that tells me that 656 pixels is 100 micrometers. So we go back, analyze, we go to set scale, we say 600, 656 is equal to 100 units here. We do UM micrometers. Okay, we do OK. Now when we go back, let's see if this works. So if I go from here to here, and I take a measurement, Control M, this new one, yeah, see now instead of 666, it shows me as 98. So about 100. So we have set the scale for this picture. So if we go from here to here and do a measurement, it should be, yeah, between 0 and 10, right? So we have set the scale. Now, basically, you're going to write that number down. 656 equals 100 micrometers, UM. Okay, because for each picture, you need to set the scale anew. I'm going to clear these results. Don't save them, right? And now I've got all of my tardigrade pictures down here, and we're going to start doing the measurement. So here, I've set up a little spreadsheet in advance. This is what you're going to use for your lab report. This is what you're going to use in lab next week to analyze these numbers with Excel. So your first column is going to be your specimen numbers. So we see F18.5, right? F40, 54.6, pond log 1, 2, RU34, and then I've got RU11 underscore 1. RU 11 underscore 1. Okay. So here's my individual animals, and the first measurement we're going to take is body length, tip to tip. So I would start with the first one on your spreadsheet, and we're going to go to Analyze. We're going to set scale. We're going to do 656 equals 100. Okay. And then we're going to go from tip to tip. Control M. So that tardigrade is 425 micrometers long. 425.1. Okay. Next, F54.6. Go F54.6. We're going to go Analyze, set scale, 656. And this is a pain in the butt, but it really does not take long. And we're going to do okay. And then we're going to measure from tip to tip. Control M. This one. Oh, there we go. Is 358.6. 358.6 micrometers. Next, time log 1. Pull up time log 1. We're going to analyze, set scale, 656, 100 micrometers. I don't know that you really need to set the units, but okay. And we're going to do our measurement from tip Control M. That one is 725, so we have a lot of variability here. 725.4. Okay, RU 34, and set scale 6, 100. Let's just see if it does anything if we just per unit. It's going to give us a number. Doesn't really matter. We know that it's not kilometers. We're going to go from tip to tip. We're going to Control M. 572.7. 572.7. 572.7. RU11 1. Let's go. You guessed it. 66. 100. Okay. Tip. Tip. Control M. 487.8. 487.8. Okay, so you just go through and you get all your length measurements, okay? Now, the other variables that we have here are related to the buccal tube, and then these last two are related to the claws. So let's look at the buccal tube measurements. Okay, and there'll be handouts that will show you how you measure buccal tube length, stylo support length, buccal tube anterior diameter, posterior diameter, standard diameter, so that you will have no question about how to actually take those measurements. We can close these guys out. Don't save. Don't save. Yep. Also, don't save. You guys do. Don't save. We're going to clear our results. Don't save. We're going to go back here, and we're going to pull up our equal to measurements. This is quadratic, so throw in. Now, keep in mind, we now have 400x. Okay, I'm going to make sure that all these are 400x equal. Yep. Okay, we have, and I'm just going to grab a few. This one doesn't say, but it is 400x. We're going to do, this one is not named correctly. Dialog 1-2 400x equal. Okay, we're going to throw them in there too. And we need our ocular micrometer. Go back, we get our 400x. We'll throw it in. Okay, same process. Okay, same process. We need to figure out how many pixels are equal to 100 micrometers. So we're going to go, we're just going to take our measurements. We're going to start here. We're going to go to here, M, from here, here. Do one more. I want everybody to do this, not just have one of you do it and share all your results. Right? This is useful skills to have. Okay, so pretty good consistency. And now this makes sense. The other one was 650 at 200x. Now it takes, let's see, yeah, more pixels to go the same number of micrometers, because when we zoom in, this 100 micrometers looks a lot bigger. So we're going to results, we're going to summarize, we're going to say the average here, 1321. 1321 equals 100. 1321, write that down. 1321 and 0.2, we're just going to go 1321 equals 100 micrometers. Okay, we're going to clear these out because this is going to be confusing. We don't need this one anymore, and we're going to start to add in our equal to blank. So we'll start at F18.5. F18.5, okay. So the first one, equal to the length. We go from front of the equal to shown here to the back of the equal to back here. So, but we can't do, no, if we do measurement right now, let's try that. We do across here to across here, and we do Control M, and it tells us that the length is 414, which makes no sense because the entire animal was only 425. Why is this so high? Because we didn't do our set scale. Don't save it, we're going to go analyze, we're going to go set scale, we're going to do 1321 to 100. Okay, then we're going to redo this. I'm going to go from back here up here. We're going to Control M and 31.9. 31.9. That makes a lot more sense. Okay, we're going to go next to 54.6. We're going to pull that little baby up. We're going to go analyze. We're going to go set scale. 1321 to 100. equal to appears here to the back of the vehicle. I find that these things are often sort of asymmetrical. So, like in this case, is it here or is it there? I want to fix it right in between these two. Okay, and do Control M, and this tells us 34.6, 34.6. Oh, what the heck? 34.6. Okay. We're going to go to pilelog 1-2, pull up pilelog 1-2, and you want to sit still. 21, 100. Okay. And we are going to measure from back here to M 57.8. 57.8. So considerably larger, but look at the animal is almost twice as big too. So that does make sense. You need to kind of keep in mind that at least an order of magnitude. If you're an order of magnitude off, then you probably did something wrong, right? So just kind of look at these. Does this make sense considering it's almost twice as big here? Well, it is proportionate to the body length. Are you 34? Really? Oh, we just had those three. Okay. And then there are these other diameters. Let's do a couple of those while we're at it. And we'll just stick to pilot 1-2 because we've already set the scale, and so this measurement will be just as easy. So we have stylet support length. This one's a little bit challenging. It goes from the anterior end of the tube back to where these stylets insert. But if I'm being honest, I can't really see it on a lot of these specimens. So in fact, I'm just going to delete this variable. But so we have the buccal tube length, and then we're looking at some diameter. Interior diameter is from interior diameter, that is interior diameter. Let's see, that's obviously the anterior end. So we're looking at from the outsidemost part here to the outsidemost part here. Hold on one second. Okay, let's see. Yeah, from here to here, I'll do Control M. That's probably, just looking at it, should be actually roughly the same as the length. It's kind of like a box shape. No, get the 57. That was our measurement here. Let's do it from here. M 44. So this is for pilot 1-2. It's 44.1. 44.1 is the interior diameter. ideally, you do all these at the same time. The buccal tube length, anterior diameter, posterior diameter, and we'll probably take the standard diameter out of there too, because that relates to the stylet support. So it's basically just anterior and posterior diameter of the buccal tube. So it's up there, and then it's back here, posterior end. That side. So M 37.7. 37.8. Okay. So throw this one out. Don't say we're going back to 34. No, we're going back to this is 54.6. Yeah, here it is, 54.6. So we're going to do we better be between length. I don't know if this is still calibrated or not. Let's give it a shot. Give it a shot. Yeah, looks like an 18.6. 18.6 buccal tube posterior diameter from here to here. M 17.8. So on and so forth. Okay. And again, just check, does this make sense at all? Well, the length is 35 and the diameter is a lot less than that, which makes sense. This is a pretty narrow buccal tube. And the posterior and anterior are about the same. So yeah, these do make sense. So you're just going to proceed through, and for your 10 specimens, you're going to take the body length 1, 2, 3, 4, 5, 6 specimens. Okay. Once you get started on this, this will go pretty quickly, and you can fill out your spreadsheet. Okay, and then we're going to combine all of our data together, and we'll have a big data set to do some analysis on, which is pretty cool.